Welcome back, class. In this video, we're going to go over the area and perimeter example of optimization problems. And we'll start by reading the problem. A rectangular plot of farmland will be bound on one side by a river. That's important because on the side that you have a river, you're not going to be needing any fencing. And on the other three sides, you're going to have a single strand of electric fence. You have 800 meters of wire at your disposal. The question is, what is the largest area you can enclose? And you also have to give the dimensions that will give that area. So let's draw a picture. So here's my river. And I'm going to change color here. And I'm going to draw my other three sides. It says it's rectangular. So everything in green needs needs fence, but the blue does not because you can't put electric fence in water. We're going to keep in mind that these are congruent. And of course, the third side isn't necessarily equal to the other two. So instead of going to the feasible domain right away, I'm going to go ahead and try to come up with my equation that I'm trying to optimize. Keeping in mind, I'm going to call this perimeter or really total fence. Just call it perimeter. It's going to be 800 meters. So that's the one thing I can't change. That's the one thing I have access to and I cannot change. So it says create an equation for the quantity being optimized. Well, the quantity being optimized is area. So I'm going to go back and look at this rectangle. The area here is going to be base times height. And so in order to do that, I need some variables. I'm going to go ahead and call this x and this y. You could call it b and h or whatever variables you want, but I like x horizontal direction, y vertical direction. And so it occurs to me that the area would then just be x times y. And remember, we're trying to optimize. We're trying to maximize the area. So there's my area equation. Only problem is that we have two variables. You cannot have two variables and take a derivative because this is not a related rates problem. We don't have any rates given to us, so we can't use that. Instead, what we're going to do is we're going to try to replace x or y using that other piece of information we know, 800 meters. If this is x down here, then this is going to be x up here. And we know that if we add the two x's, we get add the y, we should end up with 800, which means that y is the same as 800 minus 2x. That makes sense. If I have 800 meters of wire and I take away the two x's, whatever's left over, that should be my y. But what it also allows me to do, now that I know y is 800 minus 2x, is I can actually replace y with that quantity. And I get a equals x times the quantity 800 minus 2x. And I now have an area equation that is in terms of x only. I still haven't done a derivative. I don't have any critical points. I don't have anything. But I do have an equation that is in one variable, and that's important. Before I move on to finding and testing critical points, I'm going to go ahead and try to find a domain for my problem. And since the variable we're focusing on is x, I'll ask myself, what's the smallest value of x I could have? That's 0. In that case, we would just have one really long line for all the perimeter would be used in y. So that's definitely not going to be my answer, but my critical point will be between 0. And then the other thing I could do is I could stretch this out until basically y disappears. And if I stretch that out, I have 800 meters to work with. That means I'll have to divide that by the two sides. So basically, if I stretch out this rectangle, the y gets smaller and smaller and smaller until it disappears. And I end up with two just lines of fence side by side. That would, of course, be 400 to total 800. So my answer is going to be somewhere between 0 and 400. You could do this in the calculator with the derivative function. I'm going to just distribute. I'm going to do this one by hand. I think it's pretty easy. This is still not a derivative. I'm just distributing. I'm going to go over here. I'm going to go ahead and take the derivative by hand so we don't forget how to use power rule, minus 4x. We're going to set that equal to 0. And we're going to find out that x is equal to 200. So this is my CP using the first derivative test. Let me switch colors so you can see the difference here. I'm going to draw my chart. And I know that my chart starts at 0. And it should go to 400. That's my only choice. And my CP right here is going to be 200. And then I want to go ahead and check the sign. So let's say I pick 1. I put 800 minus 4, that's positive, so that means I'm going up. And then I'm going to pick, 300. 300 times 4 is 1200, so clearly that's going to be a negative result. So I've proved that this is going to be a max, absolute actually, it goes up and then back down. So that tells me that the largest area will happen when x is 200. So let's answer the first question. What is that largest area? Well, I can just go back to my x equation here and plug in my 200. And either one will work, doesn't matter. 200 times 800 minus 2 times 200. And then I can get the result, which I believe comes out to 80,000 meters squared. That is area. And the last piece of the puzzle is the dimensions. So I already have one. X is going to be 200. When x is 200, y is going to be 800 minus 2 times 200, which of course gives us 400. So that means the dimensions are going to be, I'll just put D for dimensions, 200 meters by 400 meters. And that's the problem. All right. Hope it made sense. Let me know if you have questions.